Good. The electrics are looking healthy. Batteries should be nearly charged. I'll just check the voltmeter. Great. Call on the science line. What's happening up there?
Stella, we've got another question for you. Well, you see these acorns? Well, they grow into trees, don't they?
Trees made out of wood, like this.
But where does all the stuff that wood is made out of come from?
Well, it comes from inside the acorn. Acorns contain all the goodness to make a tree.
It can't. I mean, it's too small.
Well, not just the acorn. It mostly comes from the soil. Trees use soil to grow and make wood.
So this wood is mostly made out of soil?
But in a different form.
I'm not sure about that. I've been thinking about trees and other plants myself a bit lately. I'm starting to miss them here down at the bottom of the sea. Wouldn't mind a few myself. Now, wood definitely grows. But where does it come from? Some plants would certainly add a bit of life to my southern laboratory, but I don't want to wait for long. I'll get Femi onto it to find me a really fast-growing plant.
To find a fast-growing plant, the best place to look is the rainforest. Well, I haven't travelled quite that far, but I have come to the Palmer Garden in Frankfurt, which is one of the largest collections of tropical plants in Europe.
There must be a good plant for Stella among this lot.
Dr. Jenny, maybe you can help me. There's so many plants around here, I'm not too sure where to start. Now, do all of these plants grow at the same rate?
Oh no, they all grow at different speeds, but I will show you the fastest.
So there are some plants that actually grow faster than others.
Dr. Jenny has lined up 3 hot contenders for this Science in Action growing competition, starting with the giant bamboo. A measuring stick next to it shows it can grow up to 10 centimetres a day. But the plant on the left's already grown up. We're going to measure this pinkish shoot, a baby giant bamboo. Next in the lineup is this creeper, which winds itself up a tree trunk. And our final contender is a tiny water-based plant called lemna, small but perfectly formed.
So, that's the lineup, but this is not a 100-metre dash. We're going to give the plants 48 hours to see how they shape up in the Science in Action growing race.
It's a staggered start. Every 15 minutes, with the creeper off first at 10 a.m. This red tape marks its starting point.
Up you go.
This green ring isolates a few tiny lemna plants. And now for the giant bamboo, a marker stick for the baby.
Marks, get set, grow.
So why do these plants grow so fast? Bamboos normally live in a rainforest with a canopy of leaves cutting out the light. They grow to try to reach the sun. But why is the sun so important? All green plants need sunlight to make their own food. The process is called photosynthesis. Photosynthesis happens in the leaves. They contain a special green pigment called chlorophyll, which traps sunlight. The leaf, in all its shapes and sizes, is actually a food factory. In photosynthesis, it takes raw materials from the environment and uses them with sunlight to produce sugar. This is the food it then uses to grow.
I'm a bit worried about our lemna. How can it grow without any soil?
The raw material for photosynthesis are water and carbon dioxide.
Water and carbon dioxide, not soil. So our lemna's in with a chance then.
Certainly.
Photosynthesis can be described by an equation. Carbon dioxide plus water, with the sun's energy, produces oxygen and sugar. nightfall, with no sunlight, plants can't photosynthesize. But as the sun rises, the food factories are back to work again.
Well, it's 2 days later, almost 10 o'clock in the morning, and just 48 hours after our initial measurement. So shall we see how our plants have done, Dr. Jenny?
Yes, please have a look.
Ah, look, it's done really well. It's curled all the way up there.
Might look rather nice curling up one of Stella's columns. The tiny lemna doesn't look too impressive, but remember how much we started with. Not very decorative. But now look at the giant bamboo. Over 30 centimetres of growth in 2 days, and a very attractive specimen. That's the plant for Stella? Or so I thought.
We always have to cut them down, otherwise they would break through our roof.
They grow through the roof. I don't think Stella would like that very much.
Don't worry, I have an alternative.
Ah, fast-growing, easy to care for, very attractive flowers. Well, maybe they're not quite so exotic, but at least they're safe. Thank you. They're just the job.
Will my sunflowers have everything they need for photosynthesis? Plenty carbon dioxide in the air, a regular sprinkling of water, light. There's no sunlight down here, but the right sort of artificial light does just as well, so they can produce oxygen and sugar. A sunflower might produce this much sugar in perfect conditions on an 18-hour sunny day. And a banana tree with its lovely big leaves might produce this much. And this youngster, with 100,000 leaves, can produce a massive 30 kilograms of sugar in a day.
Wow, a tree makes all that sugar in a day. But where'd it all go? Trees aren't made out of sugar, are they?
No, just wood, leaves, no sugar.
Yeah, and sunflowers aren't made out of sugar either.
The sugars are made in the leaves and then transported through the plant through the stem. Once in the stem, the sugars are converted into other materials like cellulose, proteins and oils. The stuff that this wood and these chunky stems are made of. And this is where the soil comes in. Flower food, plant food, fertilizers and soil all provide nutrients. Plants need nutrients like nitrogen and minerals to produce materials like cellulose from the sugar. But plants only need the tiniest amount of nutrients, so most of the soil is just used to support the plant. So even though we call these things plant food, they don't actually provide food for the plant at all. The matter, the stuff that makes up most of the new root growth in this cutting, comes not from the nutrients, but from carbon dioxide in the air and water, the raw materials of photosynthesis. But how can carbon dioxide from the air make plants get heavier? A gas doesn't seem heavy enough to make heavy stuff like wood. Femi, we need an investigation.
I've managed to casually lift this investigation with a very large tank of carbon dioxide. We better get a move on. There's some plants waiting for this.
This large delivery of carbon dioxide is needed for a project to investigate the effect of carbon dioxide levels on plant growth. Claire Sterling, who runs the project, is waiting to meet me.
Listen, while Lou's unloading a carbon dioxide, why not come and have a look at what's going on? In each of these domes, we've got a selection of plants, and we're growing them under different conditions to see how that affects their growth. Come inside.
So what's special about this dome? It feels just like outside.
Well, the temperature is exactly the same as outside, but what's different is the carbon dioxide levels are actually double outside.
Really, I can't tell the difference. I can't see it or feel it.
No, but this is what all this equipment here is for, and the noise is that we're actually taking carbon dioxide from the tanker, blowing it through this hole and spreading it over the plants in each dome.
While Lou connects up the carbon dioxide, I'll show you how heavy it is.
These balloons are filled with a gas called helium. It's much lighter than air. But these balloons are full of carbon dioxide, which, as you can see, is a heavy gas, much heavier than air.
Carbon dioxide weighs tons. No wonder it makes plants heavier. Remember the equation for photosynthesis? Well, if you increase the raw materials, you would expect more photosynthesis to take place. But does it? This apparatus can actually measure how much photosynthesis is going on in a leaf. The leaf is mounted in a glass container. A trace measures the photosynthesis rate. To show it's working, first switch off the light and see the rate fall to 0, because plants need light for photosynthesis. When the light's put back on, it starts to photosynthesize again. Now, let's increase the carbon dioxide supply to the leaf. The rate of photosynthesis goes up, but does it mean the plants grow more? That's where the domes come in. This ryegrass has been growing in a dome with high carbon dioxide levels. To measure the growth, Claire trims an area of grass to a fixed height and collects the clippings. I'm off next door to cut the ryegrass growing in there. A dome with normal levels of carbon dioxide, a control used for comparison. The temperature and water levels in the domes are kept constant, so it's a fair test. Both sets of clippings are collected, dried, then weighed. The trimmings from the control weigh 5.1 grams, and the trimmings from the high carbon dioxide weigh 11 grams.
So it looks like higher carbon dioxide levels do mean more growth. So what's the point of this experiment? What does it tell us?
Well, the thing is, scientists know that carbon dioxide has increased in the air and is going to continue to increase in the future. So the work we're doing here really is to try and understand how that's going to affect plant growth. Listen, why don't we check on the results of a little experiment?
Okay.
Yours is in this dome and I'll go and see the ones in here.
6 weeks ago, Claire planted my favourite seeds, sunflowers. She left some in the control dome and some in the dome with higher carbon dioxide levels. So how have they done?
Oh no, yours is bigger than mine. Mind you, that's because your dome had more carbon dioxide in it.
That's right, more carbon dioxide, more growth.
But I refuse to be beaten. Ta-da! Yes, now that's what I call a sunflower. But what Claire doesn't know is I popped down to the florist earlier.
Oxygen level down here is getting a bit low. At least my new plants will help me there. Green plants are vital in maintaining the oxygen level everywhere on Earth. Oxygen we all need to breathe. When plants photosynthesize, they use up carbon dioxide and produce oxygen. This is vital for all us animals on land and sea, including my goldfish Carrot. Look closely at the pondweed. You see tiny bubbles of gas produced by the leaves. This test tube has been collecting gas for a few hours. Looks like oxygen to me.
Steel, glass, concrete, but no plants. City parks are good news. And here's a park with a difference. It's inside the building.
They're called hanging gardens. Each garden here is 4 stories high, and the 9 hanging gardens spiral all the way down through the building.
The new Commerzbank building in Frankfurt is the tallest building in Europe. Dennis Phillips has just moved into his office.
What's the point of having hanging gardens all the way up here on the 39th story?
Well, it's a great place to take a break, and of course you can meet your colleagues here and you get a lot of fresh air from these windows that open up.
And I can see you also get an awful lot of light in here as well.
Well, we do. You get a natural light. Even the inside offices here have natural light, so we save about, we hope, 25 to 30% on energy costs here. This is one of our Mediterranean gardens because it's facing in the southern direction. We get a lot of sunlight in here. We have the Mediterranean lime trees.
Just look at all that sunshine just streaming in here.
These gardens don't just look nice. There's another benefit too. The gardens and offices open out onto a central atrium, which acts as a ventilation shaft for all the offices.
In the daylight, all the plants are busy photosynthesizing, so they're using up carbon dioxide and producing oxygen. This contributes to fresher air for all the people sitting in these offices during the day.
So, great news for the office workers. But what about the plants? This olive tree didn't expect to live 30 stories up in a skyscraper. Many plants can survive in such conditions, but for some plants it can be more of a struggle. Then they become stressed.
I'm going to investigate how well some of these plants are coping with their unusual habitat. This is a plant efficiency analyzer. It's a bit like a stethoscope for plants. Now, my PEA, or P, can tell how stressed a plant is by measuring how efficiently it photosynthesizes.
The sensor shines a very bright light at the leaf portion.
A stress-free, healthy plant should give me a reading of about 0.8. Any less than that, and the plant has problems. Well, my P reckons that this bellflower is as happy as can be in its new home. .782. Could do better. Maybe it could do with a drink.
On the whole, I reckon my green patients are doing pretty well, considering their unusual circumstances. Maybe not quite as stress-free as the lucky people who work in these offices, but they're certainly doing their best to cope. But there's one plant I'm extremely worried about. However much light, water, and carbon dioxide you give it, a plastic sunflower won't photosynthesize at all.
Well, at least the oxygen level's well out of the danger zone now. I can sleep in peace. Sweet dreams, Carrot. Bedtime.
But as I switch off the lights, what's going to happen to my oxygen level now?
If it's dark, there'd be no photosynthesis.
Yeah, plants need light for photosynthesis.
So the plants won't produce oxygen, will they?
So her oxygen level will go down.
Yeah, but not much. Plants only produce tiny amounts of oxygen, don't they?
But Stella's using up loads of oxygen just by breathing.
And plants respire too. They use up oxygen in the dark.
I tell ya, she's had it.